morning, good afternoon, good evening, wherever you may be watching this from. This is Konyela Subinda with another video. So in this video we are continuing, and now we are going to go to the next example question, which is example question 3. So in example question 3, what we are doing is we are still going to use the chain rule. So these examples are all under the chain rule. Okay, question 3 reads, when x is equal to 1, the gradient of the curve y is equal to 1 divided by 3 plus ax is 2. Find the values. So it means not one value, but values of a. Okay. So the first thing that we do is we first of all write the equation. Y is equal to 1 you divide by 3 plus ax. So y is equal to 1 divided by 3 plus ax, and then we are saying the gradient of the curve. When x is equal to 1, it is 2. Then has to find the values of a. So we can't differentiate here. If you hear the word gradient, the thing that you should start thinking about is dy dx. So we need to differentiate this. Now the way it's looking, we cannot differentiate it because what we want, which is the x, the part having x is on the bottom of the fraction. It needs to go up. Okay, when it goes up, the power will change, but it needs to go up because we differentiate them in the linear form. Okay, y is equal to 3 plus ax raised to the power negative 1. So it has gone up. So this has gone up, and then it has become one expression, 3 plus ax, all of it will be raised to the power negative 1. So in this question we are going to use the chain rule. In the other video we used the core. In this one we're going to use the chain rule. Then in the next question, the next video, we're going to use the core. Okay, to proceed, we say let u be equal to 3 plus ax, y will be equal to u to the power negative 1. So du dx is equal to a, because the derivative of 3, which is a constant, is 0. And then this, since it's just a variable raised to the power 1, just get the coefficient of that variable. Okay, like that. And then now your dy du will be equal to, here, negative 1 multiplied by whatever is in front of you, it will be negative 1. Because what is in front of you is a positive 1, negative 1 times a positive 1 will be negative 1. U to the power negative 1 minus 1, you are going to have a negative 2. Be careful here, someone can even find 0. Because I don't know. If you don't know your integers very well, you might struggle there and find 0. U to the power 0, which cannot happen here. Okay, so your chain rule says dy dx is equal to your dy du multiplied by your du dx. Your dy du will be negative u to the power negative 2 multiplied by your du dx, which is a letter A. Okay, just like that. And then if you multiply the 2, you are going to have negative a u raised to the power negative 2. I hope I haven't lost anyone. What I've just done is I want to write this in one term. So I multiplied these 2. Okay, then I got the negative sign there, but the power negative 2 is still with u. Okay, so that is your dy dx. But in the question, there was nothing like u. So where has this u come from? Hence, we need to substitute it. We said let u be equal to 3 plus ax dy dx is equal to negative a u, which is a 3 plus ax raised to the power negative 2. That's your dy dx. And then they are saying the gradient of this curve at the point where, so I'm saying when x is equal to, at the point, at the point where x is equal to 1, the gradient, which is m, is equal to a positive 2. So your dy dx is a gradient function. It's a function that can help you find the gradient. So you're going to say that your m is equal to negative a multiplied by 3ax raised to the power negative 2. Okay? And then we're saying let x be equal to 1 and m be equal to 2. So 2 is equal to negative a multiplied by 3 plus a. A will just erase the power, a times positive 1, and then as we saw that all of this is being raised to the power negative 2. And then we can simplify what is in the brackets. Okay? 2 is equal to negative a, you multiply by 3 plus a, like that. But let's not forget, this is being raised to the power negative 2. Like that. And then we can now clean up, since we have gone to another part of the question. We can now just clean up. Okay. So this, which is in the brackets, is called the core. We have got rid of x because we said x is equal to 1. A times 1 will just be a. So here, let's make this index as the power negative 2. Let's make it power positive 2. So 2 is equal to negative a divided by 3 plus a raised to the power 2. At this point, we can cross multiply. We are going to have 2 multiplied by 3 plus a squared is equal to negative a. And then we expand this bracket here. So 2, expanding this bracket to not waste time in additional mathematics, we are allowed to just use the shortcut, which is you square the 3, you're going to have a 9. 3 times a is a 3a. 3a times 2 is a positive 6a. A times a is going to give you an a squared is equal to negative a. And then to proceed, you just distribute the 2 inside the brackets. You're going to have 18 like that. So 18 plus 12a plus 2a squared is equal to negative a. If you distribute the 2 properly, that's what you're going to have. Okay? And then we have a negative a here. As you can see, this is becoming a quadratic equation where the highest power is a 2. So you have a 2a squared plus 12a. When the a goes to the other side, it will become plus a, then plus 18 is equal to 0. 2a squared plus 13a plus 18 is equal to 0. That's the quadratic equation we have. Okay, so for me, I'm going to solve it by completing the square. You can solve this by using the quadratic formula, or you can solve this by completing the square. But I think if you solve this very well, it need to be factorized. Now it means that we might take longer. So 18 times a 2, which we are finding the product. 8 times 2 is a 16. 1 times 2 is a 2, 36. So these two numbers can give us 36, and then when we add, they give us a 13. Okay, so the product is 36. Now which two numbers should you add to get a positive 36? Okay, there is a 9. okay, a 9 and a positive 9 and a positive 4. So if you multiply 9, okay, let me write it in a way that you can understand. So the product is equal to this number in front of the one which is being squared is a 2 times 18, which is a 36, and then the sum is this number which is in front of the one just having a. This a is being raised to the power 1, so the sum in this case is 13. Now the factors are which numbers, if you multiply, they give you 36. Okay? This times this is 36. And then when you add them, they give you 13. That is 9 and 4. Okay? Positive 9 and positive 4. Positive 9, you multiply by positive 4 is 36, and then positive 9 plus positive 4 is going to give you positive 13. Okay? So what am I going to, how am I going to do this? It's 2a squared. Then in place of your 13a, you're going to write these two factors, which is 9 and 4. So you're going to say plus, okay, plus 9a plus 4a plus 18 is equal to 0. We haven't changed anything from this equation because 9a plus 4a is still 13a. We have just written it in a different form. That is mathematically correct. That's all. So, nothing to get confused there. Then to continue, we need to factorize. So, factorizing, we're going to use a method called factorizing by grouping. So, I'm going to group this together and this together. So if we group those two together, we are going to find something that will be common. That's how you know that you are moving on the right path. You're going to find something that will be common in the brackets, and then from there you just continue. Okay? So I've grouped these two terms together, these two terms together. What is common here is just a. You factor out a, you're going to end with 2a, like that, as you can see. I hope you can see that. 2a plus a 9. Then here to be plus, you maintain the sign that is there. Which number can go into 2 and 18? It's a positive 2. And then positive 2 into 4a is going to be a 2a. Positive 2 into 18 is going to give you a 9. Is equal to 0. So as you can see, we have two common brackets like that. If you see that these are common, it means you're going on the right path. So what you do first of all, you write the common bracket 2a plus 9, and then you get these two, okay? So this number and this letter, which is in front of the brackets, you get those. So start with this one here, then you go to this one. You always start here, then you go there. Alright? Here, then you go there. So a plus 2 is equal to 0. Take note, this is 2a plus 9. Maybe the way I wrote this 9, someone might get confused. 2a plus 9. Then when we reach this stage, we'll say 2a plus 9 is equal to 0, or a plus 2 is equal to 0. Then 2a is equal to negative 9. A is equal to negative 2. So we divide both sides by 2, we divide both sides by 2. 2 can go into itself 1, into itself 1. Therefore, a is equal to negative 9 over 2, or a is equal to a negative 2. So that would be your final answer for this particular question. Negative 9 over 2, or a is equal to a negative 2. So we have factorized this by, we have solved this by factorization, and that is factorization by grouping. I wanted to use completing the square, but it's okay. I just used the factorization method because it's the fastest and the easiest. Thank you so much for watching this video. Thank you so much for the support being rendered to this channel, and I believe this channel can grow. May you just like the videos and even share if possible to such a one maybe who may be struggling, okay, under this particular topic in calculus. And until the next video, this has been Cornelius Lubinda. Bye bye.